Okay, so the first leg is done. Got everything bent and bolted up. One thing I wish that I would have thought ahead of is that because I'm using the biggest drill bit I have to tap out the hole, or to make the hole so I can tap these 5/8 bolts, where I don't want threads, especially in these guys, I don't have a drill bit big enough to wallow it out, and I don't want to just, wall it out with my 1/2 inch bit. So I put a sacrificial bolt through the threads I put into the 1/4 inch aluminum, and then locked it in place and just stripped all the threads out of it. So this guy, in fact, there's part of that thread. So these no longer have threads in them. The block does, but the arm does not. So again, there'll be one of these on every face as we go around. And again, the intent behind this is that if I get into something really big, structural steel, something where I've really saturated the material, the magnetic field has really saturated all of that field can saturate. You're talking 2 or 3 inches of plate steel, which is used sometimes in marine applications. It's usually painted, but nonetheless it's there. I'm 130 pounds soaking wet. Okay, I'm 5'6", like 129. I am not the world's strongest guy, for sure. Which means if I embed this onto structural steel, I'm not going to be able to pull it straight up. We're not just going to yank straight up on it and it's going to go. What we're going to have to do is come over and get leverage to lift this thing off of it. So sideways, and what the point of these arms is to give lateral support so that we don't just strip the threads out or break the bolt down there at the bottom. Okay, so I went through with my caliper, and where we had brought these 2 lines down the side, we cut that in half, and then we cut the diameter in half, focus, to give us our center point, and then we went ahead and center punched all of them. So I realized I didn't actually film this. I swear I did, but apparently I didn't. So when I was talking about bringing these 2 lines down that I had scribed on every face, I took the thickness of the bar, the 1-inch bar we've got, and then I scribed those 2 lines straight out so that we knew where these lines were going to be facing down, and that way I could, basically I was trying to find the exact center point between this dimension and this dimension on all 6 faces. If it wasn't painfully obvious, but for now, iPro is probably something you want to have. Safety squints are probably just not going to cut it for you. Okay, so I'm on to drilling the last hole, and one of the nice things about is like flail chips everywhere. That's why I like it on. The nice things about having these lines that you scribed is that it gives me a parallel surface to match to the face of the vise, and then it gives me something that we're pretty close to being 90 degrees on when we're drilling in. It just is easy to try and take some of the guesswork out of, am I plumb and parallel to all my surfaces when I'm doing this by hand. So a couple of things I realized. Number one, if I just cut them in half, they're pretty much the perfect length that I need anyway. I don't care if there's a little bit of overhang up here. And I'm probably going to go in and redo these 2. I've got 1 bar left, so I'll just cut it in half. And that'll save me from having to file these guys down, as these 2 short ones end up being just a little proud. This guy's, about 15 hundredths, and it's not quite as bad. about 1100s. So not a lot, but it'll aesthetically, these will all be roughly the same height. I mean, they're off by a couple, maybe a millimeter high on this one, but other than that, you know, I'm happy with that. Again, probably significantly overbuilt, but on the positive side, I'll probably never break it. So if it wasn't clear before, these supporting ribs on the side really hold two functions. Number one, as we said, lateral force, they'll keep this thing from buckling over. Two, it means that I shouldn't have a problem with stuff getting hung up, getting this stuck under the bottom of something. So just finishing drilling and tapping the last of the holes, and I felt the drill bit bind, and this has done this a couple of times, and but it's typically what's happens at the top, which is fine because I'm just plunging into just the bottom of the hole for the eye bolt, which I was expecting was going to happen. But on this bottom one, for being hand drilled, it's pretty spot on dead center. So I'm pretty stoked about that, considering this has all been hand drilled and I am not the straightest at drilling holes. Alright, so as is usual, I completely changed my mind on, originally I wanted to through bolt these. In other words, one bolt went all the way through and then there would be a nut on this side. I steered away from that simply because I just don't have bolts that long, and aesthetically I think this looks a lot nicer. And yeah, that's pretty much it. It was really just about aesthetics. So since most of, well actually pretty much all of these bolts intersect, because the 3/8 tap that I have, I don't have a bottoming tap, it's just the center one. So I gotta go further than the threads are actually gonna go for the bolt in order to get enough full threads cut for the bolt to thread all the way in. So I've drawn out everything in black and half of it smudged off, but all these cross sections in black is what is left meat wise. So I'm still never gonna be able to break the thing no matter what this thing latches onto. There's still a ton of aluminum left. Okay, so new plan for, I don't know how many times we've had a new plan in this. So instead of doing 4, it makes sense, let's just do 6. And to make sure I get everything, that everything's gonna fit, I went into PowerPoint and printed off, well, first I did 2.5-inch circles, because that's what it said. Turns out those aren't actually 2.5 when they get printed, so 3.1 circles in PowerPoint actually make 2.5-inch circles. And so I've just co-located them to where they should all be roughly even, and again, I'm not worried about perfection here. I just want them all relatively in the same spot. And then I put the crosshairs in there so I can go in with my center punch, line up on the crosshair, and just put my center punch mark into all the spots. Okay, so using the same 3/8 16 National Course tap, we have all 6 holes drilled and tapped, and they pretty much came up exactly where I'd wanted them to. This one here is a little close. We're you know, 1/2 inch. The rest of these are a little bit more than that, a little over half. Yeah, so not exactly perfect, but again, this was all hand drilled. The only one I really jacked up was this one. Just it's pitched quite a bit to one side, so yeah, I don't think it's going to make any real difference. So yeah, let's get it out of the vise, clean it up, and take a final look at it. Okay, so review of final product. I got everything cleaned up. I should mention a couple things. One, I went through and I shaved all the corners and sharp parts off on both the top and bottom. Also, I went along and starting from 1, I put a cold chisel here and put a notch into each one of these, 1 on top and bottom, 2, 3, 4, 5, all the way to 6, so that when I disassemble this, so I can clean everything, get all the oil off from all the tapping we had to do, don't want to put oil all over the water, that I can reassemble it the exact same way. And then to do the bottom one, make sure that this shaft, because both are threaded, it should never not line up, but I just put one big ding on either side. Shouldn't affect any structural integrity. It's just making for ease of reassembly. But yeah, I am 100% pleased with how this came out.